we did all different kinds of expansion. We expanded monomials by polynomials. So for instance, we took something like this, we took 2x, we expanded it in, and we got 2x squared plus 10x. Right? Like that was something we did. We distributed monomials. Then we had binomial times binomial. When we had binomial times a binomial, we did distribution. We also did area diagrams, right? We did both. And it was your choice on what you wanted to do. But we found most of the time when we multiplied a binomial by a binomial, we ended up with a trinomial, which looked like this. We usually had to collect like terms. That's a 4x. The line connection on the top. And if we multiply the other two binomials together, we get the same thing. We still get trinomials. In this case, we would get 2x squared. Then we get plus 11x. And then we get plus 1. But we started to notice, hopefully, that two binomials multiplied together was creating trinomials. Almost always, right? Not all the time, but like 90% of the time it would. We also got some special binomials, these two things down here, which were very similar. We had x minus 5x plus 5. And we multiplied those things together, and they actually wouldn't create trinomials. Instead, they would create another binomial. This one multiplied to turn into a binomial like this. And that's a very special like binomial times a binomial. It has a fancy name. It's called a conjugate. You don't need to know that. Okay? But when you have two binomials that are the same thing but with a different symbol in the middle, they multiply together to become a binomial, and it's a special, these are conjugates of each other. They're special binomials because they're opposites, so they have to have a special name, right? Always seems right. Okay, that was expanding or multiplying. Now what we're going to do is we're going to factor the second half of this unit. What factoring is, I call it unmultiplying. So we're going to go the opposite direction. We're going to be getting questions like this, and we're going to turn it into that. We're going to have trinomials turn into two binomials. And then sometimes we're going to have binomials and turn it into two other binomials. It's called factoring. Okay, we're just going to unmultiply things. It's going to take us a while. Okay, we're going to have like, I don't know, 5 or 6 different days of factoring. So it's going to slowly build on itself and just keep getting more and more challenging. Today, we're going to do something called greatest common factor. We're not going to fill it. These are the same trinomials. Sorry, these are all the expanded things from out there. I don't think I need to rewrite it out again. I did the cool thing with the circle and the arrows. It was way more interesting. Yeah. Okay, we're going to start off with GCF. We've heard of GCF before. Okay, this is the first type of factor we're going to do. GCF stands for greatest common factor. We used to do this with numbers. I remember we would do the trees, and then we'd find the biggest number that divided into something. I don't do the trees for this unit. I feel it's too slow. The numbers we get usually are small enough that we can just do it kind of by inspection, by looking at two numbers and finding the biggest number that divides into both of them. And that's what a greatest common factor is. Okay, so for instance, if we look at the number 48 and 72, we could break it down using a tree like they've done. Right? Make it 2 times 2 times 2 times 2 times 3. Yeah, you could do that. Instead, what I would do is I would just look at these numbers and I'd ask myself, what's the biggest number that divides into each of those? And I'm looking for the biggest number. So you might have to try a few. Right? Like they are both divisible by 2. But 2 is not the biggest number that could go into them. 4? 24? 24 would be the biggest one that goes into them. 24 goes into 48. And 24 does divide into 72 even. If you couldn't figure that out, if you're like, I don't know, I'll show you some tricks in the future on how to know if you've got the biggest one or not. Okay, because it is kind of tricky. But remember, a greatest common factor is the largest number that divides into two things. So this one's greatest common factor is 24. Worst case scenario, if you want to use your Unit 1 skills and make those trees, you're more than welcome to. It's just time consuming. Awesome. Now we're going to talk about greatest common factor when you have letters involved as well. Okay, so if I look at these two terms right here, and I'm trying to find the greatest common factor, that means the biggest thing that can divide into each of them, I'm going to break it down into two chunks. I'm going to do the numbers, and then I'm going to do the letters. Okay, so I'm going to look at just the coefficients first. What are two numbers? So what is the biggest number that can divide into those two numbers? 3, right? I see a whole bunch of people trying to whisper it to me. It's 3. 3 is the biggest number that divides into 6 and 9. Then I'm going to look at my letters. Okay, and each letter is different. So I'm going to look at just the A's first. This one's a to the 3, this one's a squared. I'm going to ask myself, what's the most number of A's I could take out of both of those things? A hint, it's always the lowest exponent. Okay, so this one has 3 A's, this one has 2 A's. That means a to the power of 2 would be the biggest number I could divide out of both of those. And I couldn't take any more, or else there's not enough in the second term. Then I'm going to look at the B's. I'm going to say, what's the most number of B's I could take out of each term? This one doesn't have any B's. This one has 1 B. If I can't take any B's out of the first one, that means there is no greatest common factor using the B's. This right here would be called my greatest common factor. It's the biggest thing that I could divide into each term. That's going to be the first step to factoring that we do on every single question, is identifying a greatest common factor. Right, so for this guy, we would say the GCF is 3a squared. Again, you could do that process using our Unit 1 skills, just a little more tedious, I think. Okay, so class example number 1. I'm not going to do this part because I think that's a slow, very, very slow way. And if you're doing that every single question, then you're going to be in big trouble. Okay, so we eventually just have to be able to look at it and inspect it. So it says, determine the greatest common factor of 8x squared y squared and 20xy cubed. Our strategy is to start with the number. Okay, so look at the number first. 8 and 20. And ask yourself, what's the biggest number that could divide into both of those? 4, right? 4 could divide into both of those. 2 could divide into both of them as well, but we want the greatest common factor. So you're taking out the biggest number. Then you move on to your letters. First letter I see is X. The first term has an X squared, the second term has a singular X. That means the most X's I could take out of both would be X to the power of 1. If I tried to take more than that, the second term doesn't have enough to divide out. If I look at Y's now, I have Y squared and Y cubed. The most number of Y's I could take out of both would be Y squared. If I try to take any more than that, I don't have enough in the first term to take it out. So my greatest common factor is 4xy squared. Do you have any questions about that thing? It's not that bad, right? GCF, life's good? Okay. I want you to try all 4 of these. Okay? What you need to do is find the greatest common factor between these terms. So this is one term, this is the other term. They're separated with that comma sign. For D, there's 3 terms. So you're trying to find the greatest common factor of all 3 terms. Give it a shot. I will do it with you, so you'll have a minute to try it on your own. Wow, there's no button other than that. So if you look at 12ab and 15a squared b cubed, and you're looking for the greatest common factor, you break it into chunks, right? Numbers first, letters next. So if I look at this guy, 12 and 15, the biggest number that divides into both those is 3. If I look at my letters next, a squared. The most number of a's I can take out is a. If I look at my next letter, I have b cubed. The most letters I can take out is just b to the power of 1. Right? So lowest exponent is what I can take out. Awesome. If we look at B, I have 18 and 24 as my numbers. The biggest number that could go into both of these numbers, and there's a few, right? They both divide by 3. They both divide by 2. They both divide by 6. Right? So the biggest number that divides into both of them would be 6. Then I look at my letters. I have an x4, x3 is the smallest exponent, so x3. And y squared, y5, lowest exponent is y squared. And GCF, or my greatest common factor, would be 6x cubed y squared. Down here, if I look at this one, it has a 2, and it doesn't have a coefficient. That means there is no number that can divide into both of these. Then I look at my letters. This one has an a cubed, this one has an a. So a is the biggest number I could take out of both, a to the power of 1. If I look at my b's, this one has a b, this one doesn't have a b. That means I can't take any b's out. Then I look at my c's, I have a c squared. So my greatest common factor is a times c squared. No b's could come out, no coefficients could come out. Awesome. For D, this one's a little bit different because there's 3 terms. Okay, so when you're looking at this, it has to be something that can divide into all 3 terms. You'll also notice that all 3 terms are negative numbers this time. That means you would factor out a negative symbol as well, because they all had the negative in. Then I look at my numbers. 10 is the biggest one that goes into all 3 of them. If I look at my letters, a cubed, a squared, a squared, a squared is the most I could take out of all of them. If I look at my next letter, I have b, b cubed, b squared, b to the power of 1 is the most I can take out of all of them. That one's tricky because a lot of people put b squared, right? Because you could take b squared out of both of these, but you can't take a b squared out of that guy. Right? And it has to come out of all 3. Fantastic. It's not bad, right? GCF. People like GCF usually. Like I had said earlier, we learned multiplication. Multiplication was when you take a monomial and you distribute it in. You get something like this. We're going to go the other way. And that's what using the GCF is. Okay, so when we take something like this, and we want to turn it back into that, which is a multiplication statement, we say it's factored, or we take a greatest common factor out. Okay, that monomial that's out front, that is your GCF. Okay, that's why GCFs are what they are. It's just a monomial that's been multiplied in. I'll show you how it looks. So if we look at questions like this, if I'm trying to turn this into a multiplication statement, I need to figure out what the greatest common factor is for these things. I'm going to start with the numbers. 21 and 14 can both be divided by 7. The first one has an x, the second one doesn't. The second one has a y, the first one doesn't. So the only thing I could divide into both of these would be 7. Awesome. That GCF goes out front when you're creating a multiplication statement. They've given you the remainder. They've given you this part. How do you think they got that part? I think I've underlined in purple. The orange is the GCF. How are they figuring out the purple? Okay. The way they got the purple is they divided the GCF out of each thing. So if you look at your original term, they're taking 21x and they're dividing it by 7. When they do 21x divided by 7, they get 3x. Then they take 14y and they divide it by 7. When they do that, they get plus 2y. And you'll notice that this thing, the 3x plus 2y, that's what they gave you. That's your remainder. So that thing goes in the brackets and it goes beside your GCF. And that's what factoring looks like. Okay, you identify your GCF, then you divide it out to get your remainder. So looking at question B, we could do this with a trinomial as well. If you look at those three terms, you try to identify the GCF. Okay, they all can be divided by 5. If you look at the letter, they can all be divided by x squared. That's the GCF. It goes out front. That's your monomial. Your polynomial after it, they've given to you. The way they got it was by dividing each term by their GCF. So we're going to divide by 5x squared on all three of these things. When you do that, 5x to the power 4 divided by 5x squared, the 5s would cancel out. X squared divided by, x to the power 4 divided by x squared would be x squared. Right? We subtract the exponents. The middle guy, we have 15 divided by 5 would be plus 3. X cubed divided by x squared, subtract the exponents to get x. The last one is probably the one people would make the biggest mistake on. 5x squared divided by 5x squared. The reason people make a big mistake on that one is they say it cancels out and it cancels out. When in reality, 5 divided by 5 doesn't cancel out. It equals 1. You need to put 1. So plus 1. If you take a GCF out of 3 terms, you'll always be left with 3 terms. Take a GCF out of 10 terms, you'll be left with 10 terms. Okay, it'll always work that way. You should never all of a sudden go from a trinomial to a binomial or something like that. And not when you're doing GCF, anyway. You'll notice that this thing right here is this guy right here. And they've already just given you that part. I'm showing them how they got it. Fantastic. We'll do 4 together, then I'll let you try 5 on your own. So it says, in each case, the greatest common factor has been removed. Complete the factoring. So they started with this guy right here, 5a squared plus 25a. They've already identified the GCF as 5a. We need to remove it. When you remove it, what you're doing is you're dividing the original equation by 5a. They've already done the first one. So 5a squared divided by 5a would equal a. They've already given me that. Then we have 25 divided by 5 would be positive 5. A divided by a would cancel out. That means the missing term was a 5. See? For B, they've already identified the GCF for us. They've told us the GCF is a 2. We need to take that 2 out of the term to figure out what the remainder is, so we divide each thing by 2. They've already done the second one for us, negative 8q. The first one they've left blank. If you look at 18p divided by 2, 18 divided by 2 is 9. P is p. So it's 9p. For C and D, they've given us the GCF. For C, it's negative 2m. So we have to divide each thing by negative 2m. They haven't given me any of the remainder, so I'm going to have to calculate it both times. Starting with the first one, negative 4 divided by negative 2 would become a positive 2. M divided by m would cancel out. N divided by no n's would still be n. So my first term turned into 2n. My second term. Now I'm going to divide by negative 2m again. I'm going to change colors so people see where I'm getting this. Negative 6 divided by negative 2 would turn into a plus 3. M to the power of 2 divided by m to the power of 1, we subtract the exponents, bm. That would be my factored answer. Negative 2m times 2n plus 3m. Right? We've unmultiplied something. Last guy. They've told us the GCF. They've said it's 9x. We're going to divide each term by 9x to get our remainder. Dividing the first term by 9x. 18 divided by 9 is 2. X squared divided by x, we subtract the exponents. 2 minus 1 would be x to the power of 1. And y squared is just y squared. Because I didn't divide by any y. Now I do the second term. Negative 45xy divided by 9x. Negative 45 divided by 9, I'd put that in my calculator to get negative 5. X divided by x would cancel out, so there's no x's left. The y isn't divided by any y, so the y is still there. And the third term, we have 9x divided by 9x. The x's would cancel, the 9's would cancel, but we don't say it cancels, right? We say 9 divided by 9 equals 1. So we go plus 1. That is my factored solution. I unmultiplied a monomial out of that trinomial. Beautiful. There's 5 questions there. I want you to try out 5. I will do them with you after. And then we have a word problem, and then we're done for GCF. So go ahead, see if you can identify the GCF, and then remove the GCF. So your answer should be a multiplication statement, like what we had on the question above. You just have to figure out what you're dividing in each thing. Oh, lost one marker. First guy. You looked at 20x minus 6. The biggest number that can go into both of those would be 2. When you divide each thing by 2, so divide by 2, divide by 2, that gives me my leftover. 20 divided by 2 is 10. X didn't divide by any x's, so it's still x. Then negative 6 divided by 2 is negative 3. That would have been my factored answer. Okay, so when I'm looking for like an answer, that would be it. That's factored. For B, we're going to do the same thing. We're going to look at this. The biggest number that could divide into 16 and into 4 would be 4. The most number of x's that would divide into each of these would be x squared. It's always the lowest exponent. Your leftover is what happens when you divide these by 4x squared. So if we divide by 4x squared, 16 divided by 4 is 4. X to the 4 divided by x squared is x squared. My next term, I divide by 4x squared as well. 4 divided by 4 is plus 1. X squared divided by x squared cancels out. So my factored answer would be 4x squared times 4x squared plus 1. That's factored, unmultiplied, right? For C, the biggest number that could go into all those is 2. A to the power of 1 is the lowest exponent, and b to the power of 2 is the lowest exponent. My leftovers come from dividing these things by 2ab squared. 10 divided by 2 is 5. I almost said 8. A to the cube divided by a to the 1. Right? We subtract the exponent, so 3 minus 1 would give me a squared. B squared divided by b squared would cancel out. Next term, divided by 2ab squared. A divided by 2 is plus 4. A divided by a would cancel out. B cubed divided by b squared, we subtract the exponents to get b to the power of 1. The last guy, divide this by 2ab squared. 2 divided by 2 would cancel out. A divided by a would cancel out. And then I'd be left with b4 divided by b squared, which is just b squared. And it's a plus sign in between because it was a plus sign in between before. And 2 divided by 2 is still positive. Beautiful. So we can do these a little bit faster. As you get better at them, you're going to really be able to kind of rip through them. Looking at that, I can take out a 3p. I'd be left with 4p2 minus 2p plus 5. That's called removing a GCF. Very last one. That was probably the most complex. The biggest number that can divide in all those is 5, I think. The lowest exponent I see on an x is 1. Lowest exponent I see on a y is 2. Lowest exponent I see on a z is 2. So my GCF would be 5xy squared z squared. Then I put a bracket, and I put my leftover inside the bracket, right? What happens when I divide it away? When I divide it away, I'm going to be left with 5z from the first term. The x's will cancel, the y's will cancel. Looking at the second term, I'm going to be left with minus 4 x y squared. And the z's completely canceled out. The last guy would be positive 30 divided by 5 is plus 6. X squared divided by x is x cubed, because we subtract the exponents. Y squared divided by y squared cancels out, and then z to the power of 3. That would be my GCF solution, the greatest common factor solution. If you ever want to check your work, if you're ever really unsure if you're right or wrong, you could multiply your monomial back in, and you should get the same answer. So for instance, if I took this 3p and I multiplied it in, I should get 12p cubed minus 6p squared plus 15p. Right? Because then I'm just multiplying, I'm going the other way like we used to do. And you can always bounce back and forth and go opposite directions. All right, last guy. This word problem. Because the surface area of a cone is given by the formula, they give you the formula where r is the radius of the base of the cone, and s is the slant height. Determine the surface area of a cone to the nearest hundredth, so the second decimal place, which has a slant height of 7.4 and radius of 2.6. So they've told me that my slant height s equals 7.4. And they told me that my radius r equals 2.6. And they're asking me for my surface area, determine surface area. It's supposed to be area equals question mark. Whenever I have a word problem, I like to write out the info that they've given me and write out what they want me to find. So then I at least know what my target goal is. And that becomes more and more important as math gets harder and harder of actually figuring out what you're looking for. Sometimes you don't know, right? And this little step helps. So you write what they gave you, you write what they want. Then you go back to your equation up here, and you fill in all the things they gave you, and you try to figure out if you can find what they wanted. In this case, you have area equals pi r squared. Instead of r, I'm going to put in 2.6. I'm going to use brackets to do that. I actually want that square to be purple. Then they go plus pi r times s. I'm going to change r to be 2.6. Then I'm going to change s to be 7.4. So you'll notice I've gone back to my equation and I've replaced my r's and my s's with 2.6 and 7.4. I used brackets when I did that. You'll notice it's in orange. Okay, my replacements are all in orange. Everything that's from the original equation's in purple. So that it kind of sticks out to you what I've changed. If you're trying to figure out what a is, you need a to be by itself. It already is by itself, right? It's over here. So all you need to do is put this in your calculator. If you put in your calculator using the proper brackets, it should work beautifully. I'm going to need to use my calculator because I have no idea what pi times 2.6 squared is. Weird, eh? Pi is a button on your calculator, so don't use 3.14. Pi is right here. So it's a little hat button. You go second, and then that little up arrow. And that'll actually put pi, the whole digit, in your calculator. Okay, so I want pi 2.6 squared plus pi 2.6, 7.4. And I put brackets the same way I wrote them out there. I get an answer of area equals 81.68. Yes? See some? Some people look like they're not agreeing, so I'm going to double count my stuff. Yeah, that's still what I get. If you're not getting that, be very careful with your brackets. Make sure you put them in the right spot. It might even help to calculate it in chunks. Okay, so in chunks would mean I'm going to calculate what this equals, calculate what this equals separately, and then add my two answers. And then it's just a little safer. Awesome. Part 2. Write the formula for A in factored form. Okay, that means they want you to go back to this original equation up here and factor it. The way we factor things right now is we take a GCF out. Okay, so if I'm looking up there, and I'm trying to factor this, I'm looking at these two terms here. I'm trying to figure out what I can take out of both of them. I'm going to start with the numbers first. There is no numbers. Then I'm going to move on to the first symbol I see, which is pi. This one has 1 pi, this one has 1 pi. That means I can factor out a pi. This will be part of my GCF. Then I move on to my next letter. This one has an r squared, this one has an r. The most r's I could take out of both would be r to the power of 1. Perfect. I then look at my s's. The first term doesn't have an s, the second term does have an s, so I can't take any s's out. Right? It has to be in both. This is my GCF, pi r. Then I need my leftovers. So I put a bracket, and I figure out what's left over when I divide by pi r. When I divide this first guy by pi r up here, pi divided by pi would cancel out. R squared divided by r would be r. If I look at the second guy, if I divide by pi r, pi divided by pi would cancel, r divided by r would cancel. All I'd be left with is plus s. That means the factored form for area would be pi r times r plus s. That's a tricky one. It's just symbols we're not used to, right? Awesome. Part 3. It says calculate the surface area of the cone to the nearest 100 centimeters squared using the factored form. So we're going to do the exact same thing. We're going to place r with 2.6 and s with 7.4. We're just going to use this formula now instead of the other one. So that means area equals pi. Instead of r, we're putting 2.6. Bracket again. R is 2.6 plus s, which is 7.4. If you put that in your calculator, you go pi times 2.6 times 2.6 plus 7.4, you're going to find that area equals 81.68. The exact same thing it equaled before. We're not changing the value of any of our equations. We're just changing the form it's in. Right? It's like taking the number 4 and saying 4 is equal to 2 times 2. Right? It's the same thing. We haven't changed the number. We've just changed the way we've written it. That's what we're doing, but with really big expressions. We're taking them and we're changing the way they're written. Instead of multiplied form, we're breaking them up to look like multiplication still. We're factoring. Part D is kind of subjective. It says which method was easier to use, which formula was easier to use. I personally think factored form is easier to use, but I can see people who think this form is nicer too. To each their own, right? It's your preference, and you could use either one. How many people think that the factored form is easier to put in your calculator? Yeah, it's about half. How many people think like the first one better than the calculator? Yeah, so like it's truly just a preference, right? They're both the same answer. It is called verifying your solution when you do this. So, wow, Smartboard did not like it now. Verifying your solution means if you take your original equation and you put numbers in for letters, you can calculate what it equals. After you factor, if you put the same numbers in for letters, you should get the exact same value. So you verify that you haven't made a mistake, right? It's still the same thing. You do need to, you don't need to verify, but it's very useful to verify, especially if you're someone who's done early on tests. You could go verify like every question you do in this unit, which would be really nice, right, to see if you're right or wrong. Fantastic. You guys have lots of time to practice.